Greetings Calc 2 students. This video is for section 10.2 and it's calculus with parametric curves. So there are three things that we usually like to do with parametric curves in terms of calculus. The first is to find a derivative, and we use that to find the tangents at a given point. The second is to use an integral to find area, and the third is to use an integral to find the arc length. So let's look first at the derivative. So the derivative, if I look at the chain rule with dy dt, that would equal dy dt, and I'll write dx here and dx there as well. And then if I solve this for dy dx, what do I get? Well, I take dy dx, that's equal to dy dt, and divide that by dx dt. So in order to find the tangent at a given point, all I do is take the y part and take its derivative with respect to t, and divide that by the x part and take its derivative with respect to t. And that's how I find the tangent. And then I just plug in the given value for t. And that will tell me the slope of the tangent line at that particular spot. Number two, integrals. We can find the area. Well, I know that if I integrate from a to b of y of x dx, well, if I have a function y of t, then I can just plug in the value for my x's for t. So y of t, and so I just make this a function of t. And then I had x as a function of t, and I'm going to take its derivative with respect to x. So I say I have dx over dt equals, and then I'm going to have some function of t, and I take its derivative, and when I solve that, I get dx is equal to the derivative with respect to t dt. And so now all I need to do is make that equal to spot from a to b of y of x dx is equal to some new a to b. So often we say this is from alpha to beta based on the parameter. And then I have y of t times the derivative of x with respect to t dt. And all I did was use the substitution rule. So I substituted y of t as a function of t in for y of x, and then I substituted dx was equal to x of t, take its derivative, and then dt. And then finally we have the situation of the integral to find the arc length. So in this case, what I want to do is find the arc length is equal to the integral from alpha to beta of the square root, the x stuff, take its derivative with respect to t, and square it, and add it to the y stuff, take its derivative with respect to t, and square it. Of course, all underneath the square root, and that's dt, and that will tell me my arc length. So these formulas are something that you could derive each time, or you can memorize them. Let's look at an example. Using the cycloid with radius equal 2, so I have x of t equals 2 times t minus sine of t, and y of t equals 2 times 1 minus cosine of t, and I'm going from 0 to 2 pi. Find the tangent at t equals pi over 2. So the first thing I want to do to find the tangent at the place where t is equal to pi over 2 is find what is dy dt. And so dy dt would be take the derivative of 2 times 1 minus cosine of t and take its derivative with respect to t. And so I'd have 0 minus 2 times sine of t, and I have to multiply that by minus 1, so that would be plus. And so that's equal to 2 times the sine of t, and we're evaluating that at t equals pi over 2, so we have 2 times the sine of pi over 2, and that is equal to 2 times 1, or just 2. And then in the x equation, dx dt, we have 2 times t minus sine of t, and take its derivative with respect to t. And so that would be 2 minus 2 times cosine of t. And at t equals pi over 2, we would have 2 minus 2 times the cosine of pi over 2, which would be equal to just 2. And so the slope of the tangent line, or this m, dy dx, if we wrote it as an equation in Cartesian form, would be equal to dy dt divided by dx dt, and that would be 2 over 2, which is equal to 1. So we have the slope, and if we wanted to write it in point slope form, we need a point. So at t equals pi over 2, x of pi over 2 equals, well, this would be 2 times pi over 2 minus the sine of pi over 2, and so that would equal 2 times pi over 2 minus 1. And so we have pi minus 2. And then also with y of pi over 2, we would have 2 times 1 minus the cosine of pi over 2, and that's just equal to 2. So our x coordinate would be pi minus 2, and our y coordinate would be 2. That would be our xy coordinate at t equals pi over 2. And so to calculate what our Cartesian tangent line would be, well, I have y minus the y part, so 2 is equal to m, and our slope m is 1, so 1 times x minus the x part. So that would be our Cartesian equation. Now we can simplify this a little bit, right? I can add the 2 to both sides, so I'd have y is equal to, and then I have x minus pi plus 2 plus 2. Distributing this negative sign and adding 2 to both sides. And so that simplifies to y equals x plus 4 minus pi. All right, well, let's take a second and look at a graph of this. So what I've done is graphed this parametric equation that we have, where the radius is 2, and then t minus sine of t for the x part, and the radius is 2, and then 1 minus cosine of t for the y part, and it's from 0 to 2 pi, and so that's this curve. And then the point that we're interested in was when t was equal to pi over 2. And so that corresponds to the point pi minus 2 comma 2. So that's this point. And then the tangent line was y equals x plus 4 minus pi. And so then that's the tangent line that just touches that point x minus 2 comma 2. Next thing I want to do is find the area underneath the curve. So I have the integral from alpha to beta of the function with respect to t times x, take its derivative with respect to t dt. And so that's equal to from 0 to 2 pi, and y of t, the y part, of course, was equal to 2 times 1 minus cosine of t. So this is 2 times 1 minus cosine of t. And the derivative of the x part is 2 times 1 minus cosine of t. So 2 times 1 minus cosine of t, and then dt. So when I simplify that, I have 4 integral from 0 to 2 pi, and then 1 minus cosine of t squared dt. When we work that out, we will have 4 times 3 times pi. So the area underneath one sweep of the curve is equal to 12 pi. Okay, and then finally is the arc length. The arc length is equal to the integral from alpha to beta of take the derivative of x with respect to t and square it, and then take the derivative of y with respect to t and square it, and then take the square root of the whole thing, and then dt. So in this particular case, I've already taken the derivative of x with respect to t, which remember up here was 2 minus 2 times cosine of t. So this is 2 times 1 minus cosine of t, and then I have to square it. And then plus I take the y, which again I've already done, take its derivative with respect to t. So that's 2 times sine of t. So this is 2 times sine of t, and then I square it. And I take the square root of that with respect to t, and I integrate from 0 to 2 pi. When I evaluate this integral and simplify, I will get equal to 16.